Good afternoon, everyone. Welcome you all to the second session of Day 3. At the outset, I deem it my pleasure to extend a warm welcome to our resource person, Dr. Manjunatha Mahadevappa. Before we start, participants, please note your mics are muted by default. Use chat box for any queries and questions to the speaker. You can pose the questions during the presentation and it will be answered during Q&A session. The slides by the speaker will be made available to the participants based on speaker's discretion. The recording of the webinar will be available on SJC YouTube channel in a week's time. The webinar is purely for gaining knowledge and self-improvement. Feedback link will be mailed to the participants at the end of Q&A session. Please fill and submit it before 6 p.m. E-certificates will be issued to the participants who attend all the sessions and submits the feedback form of every session. Now, I deem it my privilege to extend a warm welcome and introduce our resource person, Dr. Mahadevappa Manjunath, to you all. Manjunatha Mahadevappa received the BE and MTech degrees from University of Mysore, India in 1994 and Ph.D. degree in Biomedical Engineering from Indian Institute of Technology, Madras, India in 2001. In 2001, he joined Doheny Eye Institute at University of Southern California, Los Angeles, USA as postdoctoral research fellow. During 2004 and 5, he worked as postdoctoral scholar at Department of Biomedical Engineering, University of Kentucky, Lexington, USA. He is presently an professor at the Indian Institute of Technology, Kharagpur, India. Dr. Mahadevappa is a senior member of IEEE EMBS, fellow of the Institute of Engineers, and also a life member of Biomedical Engineering Society of India. He has published over 50 peer-reviewed research papers, books, and book chapters on medical imaging and advances in therapeutic engineering. His H index is 22 and I-10 index 45. He's served as the conference co-chair of the IEEE International Conference on Point-of-Care Healthcare Technologies in 2013. His research interests include biosignal processing, medical image processing, biomedical instrumentation and biosensors, retinal and neural prosthesis, electrical retinal stimulation, and rehabilitation engineering. He is currently serving as Associate Editor of IEEE Journal of Translational Engineering in Health and Medicine. We are really delighted to have you here, sir. Welcome to you, sir. Over to you.
Good afternoon to all of you, and I welcome for this afternoon session. Today I would like to present what are the funding agencies that are available for all the researchers in India and who are trying to carry out their independent research of their area of interest. And to start with, so I would first touch upon the Science and Engineering Research Board that is being monitored and controlled by the Department of Science and Technology, Government of India. So in short, we call this as SERB. So what is SERB? It's a Science Engineering Research Board and is a statutory body established through an Act of Parliament, and this board supports the basic research in emerging areas of science and engineering, which are primary and distinctive mandate of the board. And the board structure with both financial and administrative powers, and that would a researcher in any academic institute or in a research institute can seek support to carry out his research work of his area of interest. The board also gives special attention to young scientists below the age of 35 years with relaxation to certain category of students to undertake independent research in newly emerging and frontier areas of science and in addition to that, uh, the department also supports high priority areas supported by through the intensification of research through the high priority area. In short, it is called IRHPA program. And the department also supports for a scientist, uh, one of national, recognized fellowship known as J.C. Bose National Fellowship for their outstanding performance and contributions in science and engineering. And Ramanujan Fellowship is another such fellowships for brilliant scientists and engineers from all over the world to take up scientific programs, research. Those students or scientists who would like to return to India from abroad after their gaining certain amount of experiences. This board also provides financial assistance for presenting research papers in international scientific events. Like as a research scholar in India, he may carry out his research work either in an institute or an industry, but he will be able to get the support for presenting his work in an international scientific events. And this supports for all attending all national as well as the international programs. The goal of this program, that is SERB program, is to stimulate for to do the research and to gain new knowledge and encourage the invention, discovery, innovation and development by supporting bottom-up research competitively and at all levels of the research ecosystem. And it supports conceptually new directions, though it is a risky directions, but having a potential for non-incremental and transformative success. In the sense, the research should not be an incremental in nature, it would be more transformative in nature. And strengthen the deep expertise in specific domains and link them through interdisciplinary or multi institutional top-down programs, which addresses the challenging of the national importance. And it also supports to develop funding programs which connect with the needs of our society and identify key scientific questions, both basic science and applications that have concrete to the societal values. And also to launch and strengthen the programs to bring in researchers from the underrepresented regions, the weaker and marginalized segments of this society. So realizing the importance of gender parity, the board also ensures that appropriate programs proactively have a mechanism to encourage enhanced and equitable representation of women scientists. Overall eligible this program. So the nominee should have completed individual scientific SCRB projects in previous 3 financial years, and generally should have a good grading at the completion of this project. And he must hold a regular academic or research position in a recognized academic institutes or a national laboratories. The age of the nominee should be anywhere from 40 years to 50 years. And the principal investigator who have an ongoing fellowship or a honorarium of such fellowships may not be, or not eligible. Coming to the selection procedure, the application would be by nomination, and there will be a call for nomination made once a year, and nomination should be made by the head of the institutions. There are two stages. One is a preliminary scrutiny stage, and they check all the eligibility criteria. And once that is completed, only those nominations are found eligible would be taken for the stage 2 selection process. Then SERB has also adopted a scientific social responsibility policy to imbibe a culture of social commitment among SERB grantees. The policy intends to effectively utilize scientific infrastructure and expertise of SERB grantees to benefit other science and technology stakeholders, especially the less endowed researchers and the society. And this SERB also undertakes some scientific social responsibility activities during their project period, and depending on these activities, the additional budget could be provided under separate activities, chosen activities. Coming to the instructions on how one can submit applications, is that the person who is interested should register in the SERB online portal. So once you have registered, where you need to give all the biographic personal details, and once this completion is once the application filling is completed, then one has to choose the scheme called STAR STAR program, and this STAR nomination would include the completed projects and other scientific contributions and other details. So after filling this, the PI should go for a nominator and receive the nomination by email, and nominator can choose to submit the nomination to SERB or resend the form to the nominee. Once it is submitted, PI and nominator will receive an intimation that it is successfully submitted. And after that, what are the documents that is required is if anyone completed previous projects, then we should have a project completion report, a list of publications resulting from the completed projects and all the other prior publications, and the reprints of the publications, details of patents if he has completed any patents, and the relevant patent documents. And after the patents, if there is any document related to the technology transfer to any industry, that would be also be should be included. Also, a list of complete publications, patents, and any other significant contribution. Finally, endorsement certificates from the PI, and also endorsement certificate from the institute where he is currently working should be submitted. So coming to the second core of second type of the grants, known as the core research grant. So this is in based on an extramural research funding. So here in the extramural research funding, the SERB generally awarded to an academic institution or research laboratories and other R&D institutes who carry out the basic research in all frontiers of science and engineering. And this has been done for for a long period of time. So this scheme encourages emerging and eminent scientists in field of science and engineering for individual-centric competitive mode of research funding. Since the scheme provides core research support to the active researcher, the existing name extramural has been renamed as a core research. And so the objective of this core research grant is that supports to active researchers to undertake research and development in frontier areas of the science and engineering. And eligibility here, once again, he should be an Indian citizen. It is also, allowed with a foreign national, I mean, Indian national who is staying abroad. Generally, we call OCI or an NRI, provided they fulfill the eligibility criteria as notified. The applicant must hold a regular academic or research position in recognized institutes or in any national laboratory or other recognized R&D institutes in India. Uh, you please make a note here that private academic institutions are also eligible with a valid UGC or AICTE approvals. So they are able to submit proposals here. Faculties recruited, eligibility, coming to the eligibility, the faculties recruited through UGC faculty research programs are also eligible. Inspired faculties, Ramanujan and Ramalinga Swami fellows are also eligible for this program. So investigator who will be superannuating during the project or already superannuated are also eligible. The PI and the co-principal, co-investigators should, hold a PhD degree in science, mathematics, or engineering, or sometimes even MD, MVS degree holders are also eligible to apply. Coming to the nature and duration of the support, this CRG scheme provides research to an individual researcher or a group of researchers working in a recognized institute or national laboratory. And the funding is normally provided for a duration of 2 years. And the grant is provided for equipment, manpower, consumables, travel, and contingency. And this grant also includes the overheads that is to be provided to the implementing institute as per the policy of the SERB. Proposals from applicant belong to national laboratories or research institute should be in line with the mandated research work of the institute. A certificate duly authorized by the head of the institution should be also submitted while as a supporting document. Mode of selection, an applicant is eligible to apply only one proposal during a call. Please make a note here that one application, suppose you are preparing one particular project proposal, so it has to be submitted to only one agency, and similar proposal, if you have submitted elsewhere, should not be submitted to another agency. So make sure that you may submit another proposal, maybe of different topic in nature, but it should not be the same proposal. Proposal after you submit, if it is technically rejected, should not be resubmitted without any substantial revision that has been made as per the review comments that were given earlier. So try to implement as much as possible, address all the technical issues that were highlighted in the previous evaluation. And once that is done, then you may resubmit, but do not resubmit the same document. Not more than one project is allowed at any given time, and however, projects under the programs of other category may be exempted. And, plagiarism is another term to look into it. The proposal submitted must be original in ideation and the content. So plagiarism in any form will not be acceptable. All submitted proposals would be subject to a third-party similarity check proposals are liable to be rejected if it is found plagiarized. So any text taken verbatim from other sources need to be identified using the quotation marks and proper references. So you need to refer and quote wherever you have taken certain lines or certain compositions that you have used while preparing this proposal. So applicants are requested to pre-check their proposals for plagiarism before even uploading this. Coming to the scientific and social responsibility, SERB as an adopted the social responsibility policy to imbibe culture of social commitment. This intends to effectively utilize the scientific infrastructure and expertise to all the grantees and to benefit other science and technology stakeholders, especially the less endowed researchers and the society. So this assessor activity needs to be chosen after approval, and depending on the activities chosen, additional budget would be provided. So these are the details of the program where one can submit. So there are different divisions based on the subject of interest, like chemical sciences covers organic chemistry and inorganic and physical chemistry. Then we have earth science and atmospheric sciences. But then we have the third one is an engineering science. So here all major engineering disciplines are covered, starting with electrical, electronic computers, mechanical, aerospace, manufacturing, then civil engineering and transportation engineering, chemical and environmental. In the life sciences division, we have biomedical and health sciences, interdisciplinary biological sciences, communications related to erstwhile science, life science programs. So these are the topics in life sciences, and then mathematical sciences and the physical sciences. There is another recently the Department of Science and Technology really proposed this National Mission on Interdisciplinary Cyber Physical Systems with technology innovation hubs. So cyber physical system is a new class of engineering systems that integrate computation and physical process in a dynamic environment. This cyber physical system encompasses the technology areas of cybernetics, the mechatronics, design and embedded systems, Internet of Things, big data, artificial intelligence, and many more. The cyber physical systems are intelligent, autonomous, and efficient, and are expected to drive the innovation in sectors as diverse as uh, agriculture, water, energy, transportation, infrastructure, security, health, and manufacturing. So it is being heralded as the next paradigm shift in the technology that can exponentially spur growth and development. So in the first phase of this program, uh, um, the following areas were considered. One is artificial intelligence and machine learning, technologies for Internet of Things and Internet of Everything, sensors, actuators, and control, data banks, data services, and data analytics, advanced communication systems, robotics and automation, autonomous systems, cyber security for the physical infrastructure. So these are all the different areas that were considered in the first phase of this cyber physical systems program. Uh, but as on today, the institute who are responsible or who are eligible to apply is limited to the top 50 ranking in the NIRF. So that is one thing. I would suggest, or I would try to encourage the institutes like St. Joseph's College to improve your ranking to as near as possible to this. There is another program called Intensification of Research in High Priority. So this is another area where it includes multidisciplinary uh, projects with multi-institutional expertise. So you have to keep in mind the disciplines you need to have many, not one discipline or a single discipline, and at the same time you need to have multi-institutes. So by combining multi-institutes with multi-discipline, so you will come up with a better solutions to the mankind. So that was the reason this scheme has been proposed. And here the routine experimental or analytical instruments like the NMR, nuclear magnetic resonance spectroscopy, or X-ray radiation, X-ray diffraction instruments. So these are these type of analytical instruments may not be supporting in this program. So this program is mainly a multidisciplinary with multi-institutional approach. Then there is another program called a Startup Research Grant. So this aims to assist researchers to initiate their career in a new institutes. So it is a 2-year grant meant to enable researchers working in a frontier areas of the science and engineering and to establish themselves and move on to the mainstream research. So the criteria for selection would be based on the track record and also the proposed project. Research grant. This in this program, the research grant is covered of rupees 30 lakhs with overheads of the institute, and the duration of this project is for 2 years. So this research grant will cover the equipment, manpower, consumables, travel, and contingencies apart from the overheads. So there is a limitation on the travel and contingency. Of course, there has been a flexibility in the proposed budget under various heads. This you have to make a note that this is a one-time career grant. The eligibility is again to Indian nationals who have an applicant should hold a Ph.D. degree in science or engineering or even MD or MS, and he must hold an academic, regular academic or research position in a recognized institutes. And applicant is eligible to apply within the first 2 years of joining his institution. The upper age limit here is up to 42 years. These are the programs that is covered here: chemical sciences, earth and atmospheric, engineering sciences, life sciences, and physical and mathematical sciences. This startup research grant was started for mainly started for the young scientist, and with early career research award and national postdoctoral fellowship. These are the two reasons it has been proposed, this startup research grants. And it covers, except for life sciences, for all other subjects, the member secretary or convener of the early career research award and national postdoctoral fellowship will also be the contact person. So you need to contact those groups. The other agencies, one of the other agency is on from the Department of Atomic Energy, that is Board of Research in Nuclear Sciences. So here those who are interested in nuclear science projects may approach this agency here. So this, in short, it is known as BRNS. So BRNS supports high quality research and development on advanced concepts of relevance to Department of Atomic Energy. And scientists or engineers working in universities, academic or research institutes, of higher learning having a regular positions in government recognized universities or academic research institutes are eligible to apply. So researchers associated with government recognized incubation centers and others can also be considered. Only limitations are those who are within the DAE, Department of Atomic Energy, NGO, and some of the scientific societies need not apply. They also offer Young Scientist Research Awards. Those who are interested with an in uh, energy research, so they can apply. This is mainly for a highly qualified young scientist with the necessary grants, which supports with the necessary grants for research setting up their first laboratories. And the age restriction here is 35 years. I would like to touch upon other funding agencies like Atomic Energy Board, Regulatory Board AERB, then Aeronautics Research and Development Boards, Council of Scientific and Industrial Research, Defense Research Development Organization, DRDO. So let me touch upon the CSIR, Council of Scientific and Industrial Research. So they offer two different schemes. One is they try to promote research work in the field of science and technology, including agriculture, engineering, and medicine. Also, multidisciplinary projects which involve inter-organizational cooperation. So preference are given to the schemes which have relevance to the research programs of CSIR laboratories. So as you know, CSIR, they have many different laboratories that are placed across the country. And depending on their laboratory interest, they propose these research schemes, mainly in the area of agriculture, engineering, and medicine. They also have the sponsored schemes. They may invite applications for research grants in specific areas of interest to their respective laboratories. And they have emeritus scientist schemes for those who have completed their tenure and they would like to still attach to their universities. They can do that. And also they provide support to superannuated outstanding scientists to pursue research in their respective fields. And research fellowships or associateships are also being given. For instance, if any student would like to start a PhD program, he can approach CSIR for their fellowships. And once he gets the grant from the CSIR, so he can approach any institutes in the country, like whether it could be a national institutes or any sponsored any sponsorship based institutes can support these candidates to do his research work. So that is the advantage of CSIR fellowships, research fellowships. In addition, they offer fellowships like Shanti Swarup Bhatnagar Award for young scientists as an young scientist awards. And so with that, I mean, you can write to CSIR for more information, and you may visit these websites and find out when they are going to call for these proposals, and then accordingly you may approach them and submit your proposals. In addition to these, they also support partial travel grants for research scholars who would like to present his work in conferences abroad. Department of Atomic Energy is another source of funding. is known as DAE. So they have R&D project fostering research capabilities and manpower development in universities and similar institutions of higher learning. They also support for a symposium and conferences. I mean, suppose if you would like to hold an international symposium or conferences to promote large-scale interaction in various disciplines, this is a place to approach. They also support Young Scientist Research Awards with the age below of 35 years uh, in their initial years of the career in R&D. DAE also supports graduate fellowships for the PhD. So I believe many of the engineering institutes and science institutes they do have young faculty members who would like to pursue their career with PhD. So they may get the graduate fellowships from Department of Atomic Energy, and but the project proposal should be of atomic energy interest. So the candidate should aspire to attain highest academic qualification, achieve basic objective of strengthening linkage between the grant in aid institutes and the research centers for benefit of advancing the pace of research in the nuclear science. So those students who are candidates who are interested in advancing their career in nuclear sciences, this is the place. And also to accelerate the speed to translating research and development into a technology products and their applications. It also support certain awards to support individual research workers with highly innovative ideas. This is the contact details. You may write to the scientific program officers of Atomic Energy Department for more information. Next, coming to the department, let's go into the healthcare projects. So for this, we have Department of Biotechnology. This is once again coming under the Ministry of Health Sciences. So here they have this is the four research and development category which Department of Biotechnology is promoting. One is medical biotechnology, agriculture, animal and allied sciences, new tools and technologies, and the fourth one is energy, environment, and bioresources based applications. So I'll give more emphasis on the medical biotechnology here. So within medical biotechnology, there are many subsections where one can approach for their project funding. One is vaccine research and development. As you know, now we are in a global pandemic era, and every country is in need of vaccine to mitigate the current problems. So we need to go for developing vaccine for a particular outbreak. So this is one such area, and this is one of the needy at the moment. And those who are working in basic sciences can approach this Department of Biotechnology with their advanced proposal on developing new vaccine or developing a new drugs for mitigating this pandemic. Then it also covers public health nutrition, then stem cell and regenerative medicine, biomedical engineering and biodesign. So within this program, they also support biomedical devices, then the diagnostic procedures, diagnostic instruments, and also the medical implants. Um, so all the three, device, diagnostics and implants, are covered within biodesign and biomedical engineering uh, category. Then infectious disease biology, chronic disease biology, mental and child health, developmental and disease biology, human genetics and genome analysis. So these are the different topics. So those who are interested to write in these specific projects in this area, so one can think about it. And next agency with reference to the healthcare is Indian Council of Medical Research. In short, we call ICMR. So this is an apex body in India for the formulation, coordination and promotion of biomedical research. This is one of the oldest medical research bodies in the world, and this ICMR has always attempted to address itself to the growing demands of scientific advances in biomedical research on the one hand, and to the need of finding practical solutions to the health problems of the country on the other. Uh, Here ICMR proposes these ad hoc research schemes, which is an open-ended research on the basis of applications uh, that received from the scientist in a non-ICMR research institutes located in different parts of the country. It also supports senior research fellow, research associate and junior research fellows. So who are all, it is encouraging all to take up research on specific biomedical topics. So Center for Advanced Research also been supported by ICMR to set up in different research areas around the existing expertise, and infrastructure in selected departments of medical colleges, universities and other non-ICMR institutes. It is also it also provides guidance for international collaboration for research in biomedical sciences, and international fellowships for biomedical scientists from the developing countries, and also international fellowships for the Indian biomedical scientists. And coming to the another area is the space. So you know already that Indian Space Research Organization, ISRO, ISRO, supports many sponsored research program. So one of the sponsored research program, it is known as RESPOND. So RESPOND is one scheme, and other one is Space Science Promotion, SSP. So the objective of the ISRO is to conduct research and development activities in the relevant areas of space science, the application and technology at university and academic institutes. So also to establish interactions between scientists working at ISRO and the academic institutes to carry out joint research in the interest of Indian space program. So these are the topics that are mainly covered in ISRO. So they are mainly interested in space science, the application technology, space communication, earth resources survey, meteorology and satellite geodesy. So these are the different areas. Also, those who are interested in space science can take up this and start writing up proposals. And Department of Electronics and Information Technology, it is known as MITI. Now it is known as Ministry of Electronics and Information Technology, MITI. So they support most of the IT enabled projects, information technology enabled projects. As you already know, information technology play a vital role in day-to-day life, and yeah, the next challenges for us is to work, and live with artificial intelligence and machine learning. So any topics related to artificial intelligence and machine learning and development of Internet of Things, Internet of Everything, and sensor-based applications. So one can think of and approach this department. So with this, I will give you a short uh, introduction on how to write a proposal. So here I would like to take a case study on real-time medical data acquisition and remote uh, soldier monitoring system for large-scale emergencies using wireless sensor networks. So this is a I'm proposing as a template for you how one can start writing a proposal. In this, we try to first what you need to do is you need to write a short abstract of the proposal. So in this, I'm proposing this that and I like to propose a design and develop an artificial and an intelligent system for a real-time automated sensor network with the goal of saving maximum number of soldiers. So here I would replace these soldiers by now the patients, because in this pandemic we are having more COVID patients. So this is another emergency for us. We are in another emergency. So this proposed system mainly consists of an array of low power, low cost wearable sensors. So these sensors are generally used for monitoring the vital physiological parameters of the victims in order to reduce the precariousness of the incident and to make a real-time data available in a remote fashion at the server in the mitigation rooms. So here, instead of me uh, addressing the war, so I would address this the situation of COVID patients. So we have many COVID patients lying in the hospital, and there are so many patients we are not able to admit them to the hospital. So they have been put. We have put them in a quarantine center. So in that scenario, you can think of developing a system with an array of low power, low cost variable sensors, which can monitor the vital physiological parameters of these patients or victims, and then you make sure that this data is available in real time in a remote server. So the remote server is kept somewhere else, and we are still able to monitor these patients' information. So this is the need of the hour. So then once you write the proposal abstract, the objectives has to be addressed. So objective of this proposal could be to develop a state-of-the-art, secure, flexible, and real-time automated system which can which can give an economical solution for remote monitoring of these affected patients. This once you develop that hardware, then you analyze the detail of different energy efficient fault tolerant systems, security protocols. Now we are connected these sensor nodes to all the patients who are placed in a quarantine, and we are monitoring all their vital parameters. So we need to know the energy efficient system which can detect without any fault, uh, and including the security of the patients. So patient security is of much importance. So you need to take this patient's data at the central server that is placed somewhere in the remote location. Then you need to design and analyze the proposed solution on a smaller scale. So once you design this, if you are designing this for say 600 patients in one first module, of course in the lab scale you may not be able to mitigate or simulate that 600 patients system. So obviously you may reduce it to maybe 5 or 10 or 12 patients system, and then you connect your sensor networks, you connect your all the sensor networks are connected to the um, server located within the department, and then you try to monitor. And this is basically your laboratory test bed. So once you have this laboratory test bed done, then you go for testing the trials, taking the trials on this system. So once the laboratory module is ready, then you go for real world implementation to scale it up to the actual numbers, maybe 600 patients center or 800 patient center, depending on that. So this is a simple. Then you have to give us a basic schematic of your proposal. So you create your own schematics and show exactly what you are going to execute. In this instant, you can see that the sensor nodes are stationed in patients at different locations, and the information that is sensed from each node are sent to the control center, where in that control center there would be a doctor or a team of doctors who are going to monitor all patients' vital parameters. So the patient may be lying, patients are may be lying in a hospital, or there is one patient coming from his home to the hospital in an ambulance, but still we are able to monitor him. So that's where this sensor network plays a very vital role in large scale healthcare emergencies. So this is one proposal where you can, once you give an objective, then you go for the complete execution of the project. And once you do that, what are the motivations? Like in an emergency situation like this pandemic, we often it poses a health risk to life and the property of both the patients, even the civilians. So in this current pandemic, we are having health risk to the patients who are being affected by the virus. Also, it is being affected to the civilians, in the sense those who are treating those professionals, the clinicians who are treating these patients, they are also at a high risk to their health. So this is a emergency situation. So this is what we have to highlight, that this is the motivation. This gives you a motivation to write the proposal. And then during this pandemic, there is a widespread death is occurring. Many are being dead. There is a destruction also, and we need an emergency medical care system. So we need to set up an emergency medical care system to monitor these patients and bring them back to normal and try to have a recovery at a fast rate. So prior to this planning, you need to have an advanced technological support. Then you need to have efficiently, you need to handle such situations involving large number of patients uh, for an effective health and the medical care response. So the goal of this emergency medical response is to have a good number of paramedics and other medical personnel and save the number of lives who have been infected by this pandemic. And this the paramedics also play a vital role in monitoring continuously those affected patients with vital physiological signals. Like, so we may be monitoring their blood pressure, electrocardiogram, respiratory rate, pulse rate, uh, on all other initial conditions. As you know that in the current situation, we are currently in need of pulse oximeter to monitor the oxygen saturation of the patients. Especially in case of this, COVID patients, we need to monitor their oxygen content in the blood, and we need to know what is their respiratory rate, whether they are able to breathe in and breathe out properly or not. Otherwise, you need to help them with an ventilator. And currently, many hospitals do not have enough number of ventilators. So we may think of designing a low cost, easy to use ventilator, and you can design a new photoplethysmography for measuring the oxygen saturation. So like that, I mean, there are many devices one can think of during this, pandemic, and develop. So that is where the motivation. So in the motivation, you need to come up with the real need of the proposal, the project which you are proposing. And then finally you say, okay, it is an automated system. It will help a large number of patients who have been affected, and it can be mitigated in a timely manner. So that's where you need to give the motivations. Yeah, and then here you write a detailed work plan. So in this detailed work plan, you include how you are going to execute the entire sequence that I have discussed. So you discuss in detail about how, where these sensors are placed in these patients, and how these nodes are each sensor nodes are connected to the local server and then to the central server, and where the main control at the hospital, one can see all the physiological parameters of all the patients connected in this server. So that is what you have to write in detail in this execution. And finally, work plan. So you give work plan in phase manner. For example, so initially you say that you are going to develop a proof of concept of the deliverables, maybe 5 or 10 patients control, and then for these 10 patients, data acquisition and control, and connecting them to the server. So each patient may require around 5 or 10, 5 or 8 or 10 or sensors. So you need to connect all the sensors to those patients, then collect the data, connect these sensors to the nodes, and from nodes to the server. So that is what you achieve in phase 1. And in phase 2, you see different performance and scalability. Uh, Further, you see whether you can bring this to an advanced stage. And lastly, you may explore the possibility of commercializing this product. This is the high level architecture, where you can see we have a base station, we have a data acquisition setups, and then there are different sensors. So each sensors are connected to each individual patients, and each individual patient has n number of sensors, maybe 5 sensors or 8 sensors. So these data will be connected to the data acquisition system, DAS, and from DAS it goes to the base station. So from the base station, one can access all the data of all the patients that are connected within this sensor node. So this is a typical flow chart. You may also write, once you give the system architecture, you can also write a flow chart. So this flow chart give you the process flow, how the process will begin and end. And once, suppose, consider we are monitoring the vital signs here. Is the reading correct reading is administered? You just check whether it is yes or no. If the reading is not correct, Then you check whether it is exceeded the limit. If it is, if it exceeded the limit, then there is a failure in the sensor or not. If it is not exceeded the limit, then you go directly to the end. That means the reading is correct. So if the reading critical limit is yes, then you need to sound an alarm, and then once the alarm sounds, then obviously somebody who is looking after that patient will be attended by the nurse or some hospital attendant. So likewise, if there is any exceed, if the vital sign monitored, that signal is exceeded the current reading, then again you check if it has been exceeded, then you give a sound alarm, and nurse will be attending the particular patient, and the victim can be transported to the other unit, or I mean they will take whatever necessary steps to be taken. This is you provide a system flow chart, and then the block schematic of how you are managing the emergency management system. Okay, so once you explain this emergency management system, then you give what are the research challenges. So what are the challenges here? One is networking and communication domain. So we have many challenges here. That is development of sensor network, hybrid networks, which supports in all layers of network protocol. Then reliability of the design and fault tolerance. Then front end and back end applications, test bed planning, design and integration. So these are all the challenges here, and then simulation for the existing network simulator. For non-supportive for such environment, need to build a new simulator. Then interconnectivity, compatibility, portability across heterogeneous vendors. So these are all the network communication challenges, research challenges. Then you highlight biomedical signal acquisition system challenges. What are the challenges? See, you know that when you are connecting these sensors to the patients, sure that sensors are placed. So if the sensor is not placed in appropriate location, then the signal may not come. So at the source itself, if we are not able to collect proper signal, then whatever signal that is being transmitted may be random signal. So we don't know. So this is a very important challenge here, that once the sensors are connected to each patient's node, it has to be properly placed and embedded. Then this signal recording based on wireless sensors. I mean, you know that all the sensors that are placed are basically a wireless sensors. So there is no typical wire connection from the sensors to the acquisition protocol. So make sure that the signal that is recorded is free of noise. Then once that is done, then you do the analysis of these signals and do computer aided diagnosis. So these are all the research challenges. So once you give this system flow charts, then you give the management, how the management system is implemented, and then the research challenges that you highlight, and finally the deliverables. So when you write a deliverable, so you have to give in detail what kind of deliverables are coming out of this project. For instance, so we are able to develop a test bed for an emergency patient monitoring in the post pandemic situation, and we are able to handle the mitigation in a timely manner, so that all patients will go home with proper treatment, and they do not have any such unattended situation that comes into the picture because of this pandemic. The see, many of the hospitals in India are not able to admit these patients because we do not have enough beds for each patient. So the patients have been turned out from the hospital because there is no space. So in such case, we may think of providing these emergency system with where we can connect these sensors to those patients, monitor their vital physiological parameters, and based on those parameters we can the physician can take a can help the nurse to deliver certain basic drugs and monitor. So physician can stay in a remote place, but still these patients have been treated. So that could be one deliverable. Then report on investigating the sensor networks and their applicability in the medical domain. Then real-time monitoring of the health conditions of patients. At the comfort of the doctors. I mean, doctor need not be there, but only the nurse can stay with the patients and collect the data. And once this data is available in the server or in the cloud, the physician can easily access through the cloud. So that is one of the deliverable. Cost reduction in the effective cost reduction. So miniaturization in the size of the sensors. Then individual reports describing the results of the laboratories and test bed setup. So these are all the different deliverables. You highlight them, and then you have to give the schedule. So generally these projects are approved for total duration of 3 years. 3 years will be given. So you highlight right from the beginning, the 0th month of the project to the 36 months of the project. You give out exclusively what activity that you carry out in each phase, and accordingly you achieve your target. So the initial phase would be, you need to recruit the junior research fellow, JRF, or project assistant. So once you do that, then you start the literature survey, then laboratory equipments. You purchase some equipment that is required for the project. So then you start your actual experimental procedures. And finally you go for conducting experimental results, or where you take some recruit some patients, though they are not patients, they may be a patient. You may call them as a patient, as a normal patient, and then record the data and do the analysis and check its feasibility of the proposed method. I would also like to highlight here, when I say that you are recruiting some patients, that means you are including humans in this experimental protocol, in this experimental procedures. So I would also like to touch upon on any projects, any biomedical related projects. When you are starting a biomedical related projects, you should have proper ethics committee approval of the experiment. Suppose in this study I am planning to recruit 20 normal subjects and do the analysis in terms of connecting sensors to their body, and then the data from these sensors will go to the sensor nodes, and from the sensors nodes I'm collecting these data to the main server. So you need a human body, or you need a human participation in this kind of experiments. So when you do that, those kinds of experiments, you need to take the proper ethics approval in order to do these kind of experiments. So after this, once you provide this um, uh, schedule, once you provide this schedule, uh, you need to give the budget. So in the budget, you have to highlight year 1, year 2, year 3, and the total amount. And then first would be your staff, equipment, and then the consumables, contingency, travel, and all. So you include all these headings, or the items, and then finally you should also include institutional overheads, and finally you add year wise and submit the. So this is about writing grants. I would like to touch upon when you include any study wherein you are including the healthy volunteers and some patients in the study, then how one should start these type of projects. So here is an example to show that I'm trying to study the signals that is known as photoplethysmography. It is a PPG. In short, it is known as PPG. This in this study, we are making use of a device known as PPG to measure the oxygen saturation of the blood. At the same time, this PPG signal mimics the signal similar to the blood pressure. We try to do certain, we use certain signal processing technique to identify an index known as augmentation index. So this is my term, augmentation index. So I try to extract this augmentation index, and then we detect some of the signatures in the cardiovascular patients. So what we do here, in order to do that, we need to submit our complete experimental uh, uh, methodology to the ethics committee where I'm carrying out this research. For instance, I'm carrying out this research at St. Joseph's Engineering College. Then this college should have a institute ethics committee, and that committee should consider, take all these applications from the researcher who is doing such experiments, whether it is a funded project from the agencies like DST, DBT, or any ICMR projects, or if the even if the project is supported within the college, even if the college is funding for this, it has this kind of experimental studies with human subjects as a participant, has to be approved by the Institute Ethics Committee. So how do you form this Institute Ethics Committee? The formation of this committee and its details are available in the ICMR website. So you can visit ICMR website and take the ethics committee formation procedures for ethics committee, and you make this ethics committee in place, and then you accept these proposals from all the researchers. So researchers, what they have to do, they have to prepare this document which I am presenting now. So in this study, these are the contents where I am using a device known as photoplethysmography, and it is basically a finger clip based sensor. I am just fixing the clip onto the finger of a subject and measuring the pulse. And then background of, I give a brief background of the study, then procedure. And here you should be where two important documents that is very of very high concern in this document is the exclusion criteria and the inclusion criteria, and what would be your sample size. And lastly, since all volunteers or the normal subjects are participating in the study, as well as some patients are also participating in the study. If I am doing this, if I am collecting this data in the hospital, where the patient is admitted and I'm taking his data. In such case, we should get the ethical clearance even from the medical hospital or a college where this work is being done. So now you see here, when a person has given his consent to participate in this study, then you have to prepare a consent form, and then the patient or a participant who is going to participate in this study has to agree for this participation. So how he is going to agree? So we give him a consent form, and then consent form he will read completely and he will try to understand by participating in this study what benefit I will get or what benefit I will not get. Once he agrees to participate, then he has to sign the consent form, and then you can start the work. Then you can give the instruction to the subject or a patient and collect the data. And again, this consent form should be in three languages, or the language. For example, generally we keep the consent forms in English, and in some places you can keep Hindi also, because majority are Hindi speaking, and also local language. Currently I am in West Bengal, so I am preparing another consent form in local language. So if you are staying in Mangalore, so you may prepare another consent form in your local language. So this is the introduction to the study, where I am recording the photoplethysmographic signal to measure the alteration in the blood volume and the blood flow. So there is, on one side I have a light emitting diode, and on the other side I have a light detector. So light will be passing through this finger, and then the diffuse light will be captured by the detector. So with this I will be able to find out there is a wave that is coming. The signal that we record is a propagating pulse wave. So this pulse wave will give us a characteristics information related to the blood flow and blood volume. So these are the two parameters we are measuring. So this is why we take this, because this is one of the most non-invasive, simple, reliable and cost effective. So this is a signal. You can have a look here. This is the device, and this is a signal that we are recording. X-axis you have a wavelength, and y-axis is absorption. And at 660 nanometer, there is a reduced hemoglobin which absorbs light more readily than does in oxygenated hemoglobin. So the reverse is true, that is at 940 nanometer, where oxygenated blood absorbs more light. So with these conditions, this photo detector will measure this intensity, and that is what we record here. So one signal is for hemoglobin, then the other signal is for the oxyhemoglobin. These two, with these signals, we are able to measure what is the concentration of oxygen that is present in the blood. So with this information, what we are trying to establish is that we study the saturation of oxygen, pumping action of the heart for every cardiac cycle. We are also able to extract the blood pressure and the arterial compliance and the aging. So these are the four different parameters we are able to extract, and these are some of the prior art of using this fingernail. So this is a literature review, some of the literatures which are supporting this study. So what is the basis of this selection? So pulse oximeter is used in many medical field for a long time, and we are using this to detect the blood flow, and it also tells us the cardiovascular indices, which will also give us an information about how complicated the procedure could be. And lastly, advantage of such technique is easy, cheap, and does not require expert supervision. So what is the main basis of this study is that whenever there is a blockage in the artery that cannot be easily detected, but for that we need to go for a standard uh, screening procedure for the cardiovascular system. But if I use this finger photoplethysmographic signal, so with these signal characteristics, that is systolic peak, diastolic peak, the dichrotic notch, and then the trough. Okay, this is the end of the cycle. So by studying these features, signal features, I'll be able to predict how stiff these arterial vessels are. So that is one way of predicting the vessel compliance using the uh, PPG signal. So this is my background. So with that in background, so this is a coronary angiogram where these PPG signal that we have recorded in the patients will be compared with the coronary angiogram. It is also compared with the Doppler echocardiogram. So one is Doppler, other one is angiogram. So what we do is we correlate this angiogram and echocardiogram, Doppler echocardiogram with the PPG signal of the same patient. So when a patient comes to the hospital, we record the PPG, we record the angiogram, we record the echocardiogram. So from there we are able to bring out the pulse transit time and augmentation index, and then we try to detect occlusion in the arteries and hemodynamic parameters. So this is the recording. So this is the procedure for recording the signal. Finger nail for the finger bed, we place this clip, PPG sensors, and then data will go directly to the computer. So coming to the inclusion criteria in this study, we recruit healthy individuals of the age group 18 to 34 age, and in this we have divided into two groups. One is control, other one is intervention. So intervention is the group where there are many cardiovascular patients are included. Control group is the one where we have included only the normal subjects or normal patient. We don't call patients, we call them as a normal subjects. So this control group includes healthy subjects where the clinical history and ECG not suggestive of any cardiovascular disease. So in the healthy group, when we record the ECG, there is no abnormality, everything is normal. So whereas in the intervention group, there are some abnormality in the ECG signal. So then this intervention again we divided into three different groups within the cardiovascular disease. So in the cardiovascular disease, one is acute myocardial infarction, and the second group include patient with clinical history of ECG abnormality. Third group, clinical history and ECG not suggestive of cardiovascular, but risk factors like age, smoking, diabetes, hypertension are present. So these three groups are all are intervention, but they are in the different grades of intervention. And the first 0th group will be your healthy group. Now this is the inclusion criteria. Exclusion criteria, so subject should not be below 18, so below 18 we should not take any students or candidates for recording. And the age upper cutoff is 38 to 40 years. Subject should not be suffering from any septicemia or renal insufficiency or diabetes. So that means they should not have any these diseases. If they have any of these diseases, they are excluded. They should not participate in the study. And they should not have any other valvular replacement in the heart. They should not have any primary, secondary diseases related to heart. And subject should not have any ejection fraction 35, less than 35. Subject should not have hypertension. That means there should not be any hypertensive subjects. And should not have any subject should not have heart rate greater than 100 beats per minute. As you know that normal heartbeat 72 beats per minute. So we will exclude any volunteer who is either in the control group or in the intervention group above 100 beats per minute with a heart rate. So this is a samples, like we have a control group 100, intervention 100 selected, and one of my research scholar did this work in collaboration with medical college and hospital in Kolkata. So I'm collaborating with a cardiologist located in Department of Cardiology, Medical College in Kolkata. So research scholar is visiting the hospital and collecting the data from these patients. And now this is the consent form. You can see this is the patient who is participating in this study needs to read that consent form, and he has to sign here. The investigator will sign here, the subject will be signing here. So that means the participant is agreeing to participate in this study with all the preconditions that, okay, by participating in this study, he may not get a direct benefit, he may get direct benefit or not. He cannot claim at the later point that I participated in this study, but there is I did not get any benefits. At the same time, participating in this study should not harm the patient also. So even principal investigator has to take the responsibility to making sure that patients have been treated properly and then he has been sent home properly. So this is about informed consent. Now, as I said, informed consent is generally prepared in English and Hindi and also in local language. So this is Hindi, this is in a local language, Bengal. And this is English. Then after this, now this study is being carried out in Medical College Hospital in Kolkata. So Kolkata Medical College, they have their own ethics committee. So they have approved this study. So this is their approval letter, which says that this has the committee examined the study of this process, and then they found this study is proper, so that the principal investigator can start working on this experiment. So they give this clearance. Once that clearance is done, we submit this again. Even in IIT Kharagpur, we have our own ethics committee. So I submit the same document with this, along with this certificate, to get their clearance. And once they issued their certificate from the IIT Kharagpur. So we have two clearances, one from Kharagpur and one from IIT Kharagpur and one from the Medical College Hospital. So now we are able to start the experiment and complete. So this is how it is done. So now with this, I'm concluding my presentation, giving you an overview on what all the funding agencies that are available for you to touch upon, and each one of you can choose your area of interest, and based on your area of interest, you may prepare your project proposals, and then you may submit this proposal to the appropriate agencies. So remember, who those who are doing these biomedical research of this nature, the agencies will also ask for ethics approval, whether you got the ethics committee approval to do this experiment. So it is better to keep the ethics approval certificate ready. Even if not, you may submit this protocol to the ethics committee, and then you submit the project proposal to the agency, and you tell them that you have submitted the ethics committee. Once it is cleared, you will submit it. So in the meantime, they may process your funding application, and that they may consider. But some agencies, they are very much restrict on this ethics certificate along with your proposal. So this is how it is done. And those of you who are doing animal experiments, see, I spoke about the human subjects, experiments with the human subjects. There are proposals with animal also. And then in that situation, the institute will have another ethics committee for animal ethics committee. So you have to give your proposal to the animal ethics committee if you are using animals in your experiment, and then get their approval. So with this, I would conclude by summarizing that I touched upon some of the agencies where you can approach for your proposals, and then gave you some brief insight on templates, how one can prepare your own proposal, taking an example on sensor based wireless sensor node based applications. And then the ethics requirement, ethics committee requirement, whoever choose to study or propose biomedical related projects. So with this, I would like to take your questions if you have any question and answers.
Yeah, thank you, sir. It was an illuminating session that has made all of us grateful beyond words. Thank you so much. The forum is now open for questions. I'll read out the question, sir.
Yes.
A participant says, I have a SERP project. How will I get excellent grading? They never mention the performance grade. Where exactly they mention the performance of ongoing SERP project, like excellence, etc. Please elaborate.
Yes, this will be done every year. Once the project report is submitted, the committee will go through the responses, the deliverables that has been given to the grantee, and what grantee has in turn submitted. For example, at the end of the third year, whether you have come up with couple of publications, or whether you have got few patents, okay, or you might have got some copyrights, and whether some projects, they even go beyond patents, and they even do technology transfer. So they evaluate all the parameters, and then they give the gradings. So you have to approach them about after submitting the feedback. These are all the evaluation parameters. One is publication in a very high standard, high impact factor journals, then any patents, copyrights, and technology transfer. So all these parameters are evaluated, and then only the gradings will be given.
Yes, the last question. Can you please suggest some sites where medical data are freely available for research?
Oh, there are many such medical data available. In fact, I did not touch upon those medical data. Depending on what type of data you are looking for. So whether you are looking for biosignals or you are looking for medical images. So what type of data is required? I would like to know about it. So if you are looking for biomedical signals, if you are looking for a biomedical signals, then I can give you some sites here. It is known as MIT BIH database. So this is a database. This is a database for biomedical signals. Suppose if you would like to collect some data on heart rate or any physiological signals, so that can be that is available. Similarly, there is one more, PhysioNet. PhysioNet is another source. So like that, there are so many sources. I mean, if required, anybody can write to me. I will be happy to reply back. So my email is written there. I mean, you can write to my email anytime, and I may share it. There are many database for images, medical images, whether you are working for MR images, CT images, or nuclear radiation based images, NMR. So depending on that, you will get. So there are so many databases available.
Okay. Participants, please note, if you have more queries, you can also contact the resource person through email ID later. Thank you, sir, for this wonderful and enlightening session. I thank Dr. Mahadevappa for being with us today and delivering inspiring talk on funding agencies for independent researchers. On behalf of college management and the organizing committee of FDP, I convey our sincere thanks to you for motivating the young professionals and research scholars by your immeasurable words, sir. Thank you so much. My sincere thanks to present media group of SJC, particularly Mr. Rajesh Raju, for the logistics support. I thank whole SJC family for being supportive always. My heartfelt thanks to all the wonderful participants for your active participation in the webinar. Thank you so much. We'll meet tomorrow at 10:30 for the next session. Thank you, sir.
Thank you.